Are you terrified of memorizing complex chemistry rules only to forget them the second you walk out of an exam? What if we could boil it all down to two simple ideas? What if chemical bonds were just unfair trades? Or what if they were just like sibling sharing? Stick around, because this simple analogy is going to make it all click. In our last adventure, we memorized 90 elements in just 7 minutes using stories. But elements rarely stay alone. They're social creatures that bond together to explore the universe and create everything around us. Now, the plot thickens as we uncover the two main ways they do this, through ionic and covalent bonds. Let's start with the trade. Ionic bonds are all about giving and taking. Imagine sodium, a metal atom. It has one electron in its outermost shell that it's just dying to get rid of to feel stable. It's like having one random mismatched sock you can't find a pair for. Then you have chlorine, a non-metal. It's just one electron short of a full stable outer shell. It desperately wants to fill that gap. So sodium doesn't share, it makes a deal. It completely transfers its extra electron over to chlorine. This is the trade. By giving away that electron, sodium becomes a positively charged ion, called a cation. And by taking that electron, chlorine becomes a negatively charged ion, an anion. Now, what do opposites do? They attract. This powerful electrostatic attraction between the positive cation and the negative anion is the ionic bond. It's not a physical link, but an incredibly strong force holding them together. This strong attraction is why ionic compounds, like table salt, form rigid, crystalline structures. It takes a huge amount of energy to break them apart, giving them very high melting and boiling points. They're also brittle. Hit a salt crystal, and it shatters along these clean lines. And while solid salt won't conduct electricity, dissolve it in water or melt it, and those free-moving ions become a superhighway for electrical current. Now, let's talk about sharing. Covalent bonds happen when atoms, usually two nonmetals, decide to share electrons instead of trading them. Think of two siblings who both want to play the same video game. Instead of one taking it, they agree to share the controller. When the two atoms are identical, like in a hydrogen molecule, H2, they share the electrons perfectly equally. This fair play is called a nonpolar covalent bond. The electrons spend equal time around both atoms. You see this in molecules like O2, N2, and CH4, where the sharing is perfectly balanced. And this sharing can be scaled up. Atoms can share one pair of electrons in a single bond, two pairs in a double bond like an oxygen gas, or as methane CH4, carbon dioxide CO2. But what happens when the sharing isn't fair? This brings us to polar covalent bonds. It's like sharing with a bossy older sibling. One atom is more electronegative, meaning it's greedier, and pulls the shared electrons closer to itself. Take water, H2O. Oxygen is a real electron hog. It pulls the shared electrons from the two hydrogen atoms toward its side. This doesn't create full ions like in a trade, but it does create partial charges. The oxygen end of the molecule becomes slightly negative, and the hydrogen ends become slightly positive. This unequal sharing, this boss baby vibe, is a polar covalent bond, polar boss baby vibe. So how do you know if it's a trade, fair sharing, or unfair sharing? It all comes down to the electronegativity difference between the atoms. If the difference is tiny, it's nonpolar covalent, fair sharing. If it's medium, it's polar covalent, unfair sharing. And if the difference is huge, one atom just rips the electron away completely. That's an ionic trade. This polarity has huge consequences, especially for what dissolves in what. The rule is, like dissolves like. Polar water is fantastic at dissolving other polar things and ionic compounds, because its partial charges can surround the ions. But nonpolar things, like oil, won't dissolve in water. They prefer to hang out with other nonpolar molecules. Need a quick trick to identify bonds? Look at your periodic table. If you see a metal bonding with a nonmetal, it's almost always an ionic trade. The metal wants to give an electron, and the nonmetal wants to take one. If you see two nonmetals bonded together, it's a covalent share. Then you just have to figure out if it's a fair, nonpolar, or unfair, polar, share, based on their electronegativity. Let's practice some chemical bonds. KBr, ionic trade, metal and nonmetal. CO2, nonpolar share, symmetrical molecule. H2S, polar share, unequal sharing. MgCl2, ionic trade, metal and nonmetal. N2, nonpolar share, identical atoms. So let's recap the ultimate cheat code. Ionic equals a complete trade, creating charged ions. Covalent equals sharing electrons. And if that sharing is unequal, it's polar. That's it. That's the core concept that will help you ace chemistry.